Hello all. This session is related to laboratory experiment that is related to assembly language programming. So ALP to perform non-overlap and overlap block transfer. This assignment is from second year computer engineering syllabus. So it is related to microprocessor lab. So statement first we will go through, and other basic details we supposed to go first, and then we will discuss about implementation. So assignment 8 and 9 are related with each other. So in one session only those two assignments can be discussed. So first is assignment 8. If you will check, write x86 bit ALP to perform non-overlapping block transfer without string specific instructions. Block containing data can be defined in data segment. Similar manner, assignment 9, write x86 bit ALP to perform overlap block transfer with string specific instructions. Block containing data can be defined in data segment. This assignment is basically related to block transfer. Two types are given: non-overlap block transfer, non-overlap block transfer, and overlap block transfer. Again, in that, using string specific instruction or without using string specific instruction. 2 points are given. First, we will check theory related to block transfer. What is block transfer? How it can be performed? And then we will check for actual logic, actual implementation point. So first we will check a basic statement, what it is and how it needs to be implemented. So program for non-overlapped and overlap block transfer of array elements. First basic thing is declare the array elements in data segment for block transfer, just whatever given in statement. Next, block transfer here refers to moving of block of data within the memory to different location. So block transfer is nothing but block of data, that is sequential data. It may be 5 memory locations data from one place to another place needs to be moved. So in overlap block transfer, we move the data to a completely new location. It is easily accomplished by copying the data using two pointers, one data byte at a time. So if it is non-overlap, it can be directly transferred from one memory location to another memory location, or one memory from where source will start, and it will copy to where destination is going to start. In overlap block transfer, the block of data is shifted slightly from the present position, that is source. Thus, some of the starting elements may overlap with old positions of the last elements in the array. They are therefore copied in reverse order. This is very important related to overlap block transfer. So with example we will discuss, but just you need to remember here, that is nothing but in overlap block transfer there is overlapping of memory location. That is nothing but whatever location used in source, it may be used for destination also, and mainly in overlap block transfer it is there. In non overlap block transfer, source location and destination locations are totally different, but in overlap block transfer, few locations from source will be used in destination, and because of that it is called as a overlap block transfer. We will check with example. So here you can check non overlapped source, that is address starting from 8001, data is 11, to 8005, data is 55, 5 elements. Destination address starting from 9001 to 9005. So source memory location and destination memory locations are different. Data which needs to transfer from source memory location block of data to destination memory location. Same data will be transferred. Maybe prior to transferring these data to destination, content of destination may be different. Okay, but after transfer, source and destination content will be same. Now check, sorry, now check here, that is in overlap. If you will check source location, same 8001 to 8005. When we will check for destination location, it is starting from 8003, which is there in source also. So just now whatever last statement we discussed, that is in overlap block transfer, data is shifted slightly from the present position, that is from source. Thus some of the starting element may overlap. So if you will check here, after transfer 8003, which is here in source also, will be changed to 11 in destination. Similar manner, 4 5 3 location from source used in destination. So source is starting from 8001 and destination is starting from 8003. So easily you can check कि few location from source is used in destination. So it is called as a overlap block transfer. Okay. So we supposed to implement this by using assembly language programming. So non-overlapping source location and destination locations will be different. In overlapping, few location from source will be used in destination. So how to implement that we need to check. One more example you can check here. This example is for non-overlapping, as you can check memory address for source and memory address for destination are different. Similar manner you can check here also, input data memory address, in output data memory address. So input, sorry, memory address is nothing but it start from 500 to 503. Memory address for destination, it start from 600 to 603. So locations are different, means non-overlapping block transfer. So few points algorithm we supposed to check first. So assign value 500 in SI. Here SI and DI are used to point as a source index and destination index. So source will start at 500 location, destination will start at 600 location. 00 is initialized to AX. So in next step, AX value is copied to DX, AX value is copied to ES. Why it is done? Because for DS offset register is SI, for ES offset register is DI. You must be aware about this. That is, whenever you are using SI and DI, their base registers are DS and ES. So these register supposed to be initialized with 0 and pointers are pointing to source and destination. Assign the value 4 to CX. CX will act as a counter. So counter value, how many elements are there, or from source, how many elements supposed to be transferred to destination, that counter value should be loaded in CX. Clear direction flag. Repeat until CX will become 0. Move string block. This is given related to string instruction. Whenever you are saying, or whenever we are using direction flag for programming, at that time remember that direction flag is for string instructions. So string instruction is used for moving element from one location to another location. Now next we will check. So implementation point of view, SI will point to source location, DI will point to destination location, AX to 0, AX value shifted to DS, and EX, as these are the base register for SI and DI respectively. Move CX with for counter value, how many elements you want to move from source to destination. Clear direction flag. If direction flag is clear, what it indicates, that is nothing but SI and DI are going to increment after each iteration. So how this instruction will work? Repeat REP move SB. Okay. If you remember that move SB instruction is string instruction which will copy content where SI is pointing to where DI is pointing. So SI is pointing to this location, DI is pointing to this location. So from source, it will copy content to destination. So where SI is pointing to where DI is pointing. And because of repeat prefix, it will repeat till CX will become 0. Just we will check how move SB work. We will check these things and then again we will go back to implementation point. That CLD instruction is used to clear direction flag, that is DF equal to 0. Now value of SI and DI will be increase. If direction flag is clear, SI and DI values are going to increase. REP instruction is used to repeat the step until the value of CX is not equal to 0. So first iteration, second iteration, okay. And value of CX is decremented by 1 at every step, that is CX equal to CX minus 1. MOVSB instruction is used to transfer byte only from source memory location to destination memory location. Okay. So if DF equal to 0, clear direction flag, DF equal to 0, SI is going to increment it by 1, DI is going to increment by 1. So again coming to this point, that is nothing but non-overlap with string instruction, just now what we discussed. So this repeat MOVSB will work till CX will become 0. At the starting, CX is initialized to 4. And after every step, SI and DI is going to increment and CX is going to decrement because of this instruction only. REP is the prefix. Now if you will check this, only change is made instead of these two instruction, this is added. So without string instruction, if you will check statement also, previous statement, block transfer, implementation logic, non-overlap with string instruction, string instruction. Here, non-overlap without string instructions. So these two instruction we will exclude, and instead of these two instruction, these are the instruction which will be added. Will work same. Whatever we discussed prior to this will work same. Only thing is here string instructions we will not use. So how it will work? SI point to source, DI point to destination, AX00, ES initialized to 0, CX as a counter initialized to 4. 4 element we want to transfer. Next is move AL comma square bracket SI. So how this instruction will work? Where SI is pointing, data will copy to AL as it is square bracket memory location. Where whatever SI value is, it will act as a memory location. So square bracket SI means where SI is pointing, whatever value at that location will copy to AL. And next move square bracket of DI comma AL means content of AL will copy to where DI is pointing. Okay. So at the starting, SI is pointing to 500. At this memory location, whatever contents are there, those will be copied to AL, and those content will copy to where DI is pointing, and DI is pointing to 600 destination location. Increment SI, increment DI. Observe here, that is we supposed to separately write, or we supposed to initial increment SI pointer and DI pointer. Okay, here for this instruction we have not incremented, automatically SI and DI pointers are going to increment. Decrement CX, counter is going to decrement by 1, jump if not 0 up. It will go here till CX will become 0. It will continue loop 4, 3, 2, 1, 0. It will come out. Every time SI will increment by 1, DI will increment by 1, and content will copy from that location to source location to destination location. Okay, this is without string instruction. Now check. Whatever we discussed up till now, that is non-overlap. Now for overlap. So assign value 503 in SI. Check here. Pointer will point to last location of the source. DI pointer will point to last location of the destination. This overlap block transfer will be done in reverse order, not from starting to end. It will start from end location of source to end location of destination. You can hand run and you can check if we will start from starting location of the source and starting location of the destination. At that time it will not work properly. Okay, for that purpose you can check things and you can hand run things. Just we will go through statement which we discussed at the starting, that is in overlap transfer the block data block is shifted slightly from the present position, thus means from few location from source will be used in destination, so it is called as overlap. Thus some of the starting elements may overlap with old position of last elements in the array. They are therefore copied in reverse order. So whatever just now I discussed, in reverse order we are going to perform overlap block transfer. So other steps are same, but this is very important and basic step. So if you will check this example also, here you can check source location. Few source location are used in destination. 3, 4, 5. These are there in source also. These are there in destination also. For source, these location having some different data, but when data is going to start or when data needs to copy to destination, at that time these location will have different data, and for this purpose only we need to copy data from source to destination in reverse manner in overlap block transfer. Okay, so SI will point to 503, DI will point to 505, and in reverse manner data is going to copy. Actually contents are stored in this location for source, and content will be stored in this location for destination. X will initialize to 0, X will initialize DS and ES with 0. Counter will be 4 elements we supposed to transfer. Set direction flag. Prior to this, if you will check here, things are clear direction flag for non-overlap. But for overlap, set direction flag, as we are going to decrement SI and decrement DI. We want to decrement that. That is nothing but in reverse order we will go. Repeat until CX will become 0. Move string block. Check things. SI is pointing to 503, which is the last location of the source. DI will point to 505, which is the last location of the destination. AX0, DS0, ES0 initialized to 0. CX4 set direction flag, repeat move SB. This will copy content from 503 location to 505 location at the starting. Then 503 will decrement by 1, that is SI pointer will decrement by 1 because direction flag is set. It will become 502. Then DI will be decremented by 1, so it will become 504. So again it will repeat, that is content where SI is pointing to where DI is pointing will be copied in next iteration. It will repeat these steps till CX will become 0. Okay. So this is related to overlap block transfer. Okay. By using string instruction. So without string also we can do similar manner which we have done for non-overlap. Few changes will required. Which changes will be there? Decrement SI, decrement DI, decrement CX. Check things. Okay, without string. And with string we can go with this. Okay. So we discuss these are the string instruction which are used in the program. Just I will discuss few important points again. That is nothing but this block transfer is by using non-overlap and overlap block transfer. So by using string instruction or without string instruction we can perform this. Just now whatever we discussed, that is very important, is in overlap block transfer we are copying data in reverse manner. Okay. In non-overlap block transfer we can copy from source to destination in same manner, in forward direction only, that is 5000 to 6000, like that we can copy. But in overlap block transfer we are going to do it in reverse order because few location from the source will be used in destination, and because of that it is called as overlap block transfer. And for that purpose, while copying data we supposed to copy in reverse manner. Just we discuss these things, so remember this very important point. In non-overlap locations are different. This is example of non-overlap. This is also example of non-overlap block transfer. Okay, here if you will check, value of source index and destination index are different. Direction flag is clear. REP move SB. Without string instruction, this we supposed to use whatever highlighted with yellow we are not going to use here because it is without string instruction. So you're supposed to write these instruction instead of these two. Okay, it will work same way. Only thing is this program or this logic is without string instruction. In overlap we supposed to pointer to end location. Reverse manner we are going to copy. SI will point to 503, which is end of source. DI will point to 505, which is end of the destination. Set direction flag, reverse manner. SI will decrement by 1, DI will decrement by 1, and next iteration will be performed. So STD, repeat move SB. 503 last location of the source, 505 last location of the destination. Few location from the source are used in destination. Okay, here string instructions are mentioned, which string instructions are used in the program. Now in next video we will check for implementation point.